Hello and welcome. In this video, we're going to be solving this inclined plane problem. So before we proceed, feel free to pause the video and give it a try. Now the question says an object of mass 15 kg is at the point of sliding down a plane inclined at 36 degrees to the horizontal. So let's draw our plane. Now our plane is inclined at an angle to the horizontal. We have angle 36 degrees, so let's have angle 36 degree. An object of mass 15 kg. So we have an object of mass 15 kg. Let's draw our object. Now this object has a mass of 15 kg and its weight will act vertically downward. The weight will be equal to the mass of the object times acceleration due to gravity. Mass of the object is 15 kg, and that will be equal to 15 multiplied by 10, which we have been given in the question, and the weight of this object is 150 Newton. Right? Now, moving to the second part of the question, it says find the least force parallel to the plane required to make the object to begin to move up the plane. Now, for every inclined plane, when an object lies on it sliding down, the object will always have a force perpendicular to the inclined plane. So there's going to be a force in this direction. The force is known as the normal force or the normal reaction. So let's represent this force with R. Also, for every inclined plane, the weight of the object can be resolved in the x direction and the y direction with respect to the plane, and I'm going to explain that. So if, for example, we have an horizontal and vertical plane, alright, and let's say this is the y-axis and this is the x-axis, alright. Now this plane can be tilted, so I want to relate this to this inclined plane right here. So if I tilt this vertical and horizontal a little bit to the left to have something like this. It's just an example. So if I have this as the y-axis and this as the x-axis. Here I'm having an angle of 90, right? That is exactly what I have here also. So just assume that I have this extending down, right? So I have the x-axis and the y-axis. So this, let's call this the normal reaction, all right, and so the weight of the object. Now take note of something. We have an angle right here. This angle is the same as this angle, and I've done a video, an introductory video to inclined planes. So I explained how we arrived at this conclusion that this angle is the same as this angle. So this is 36 degrees right here, and so this weight, let's assume that this is the weight right here. Let's pull down the weight. Right, so we have the weight here, and remember I said this is the y and this is the x. So this is the y, this is the x. So I said that the weight can be resolved to the x and to the y with respect to the plane. Okay, and so if I resolve this weight, let's say this is theta, if I resolve this weight to the vertical axis, which is the y-axis, I'm going to have it to be y cos theta, and if I resolve it, to be w cos theta, pardon me, and if I resolve it to the x-axis, I'm going to have it to be w sine theta. I've also explained this in the introductory video, how we arrived at w sine theta and how we arrived at w cos theta. And so resolving the weight to the x direction, we're going to have w sine theta. Write that with a different marker. W sine theta. In this case now theta is 36, so let me just write that W sine 36. And resolving the weight in the y direction, we're going to have it opposite to the normal reaction. We're going to have it as W cos theta. Now the question says to find the least force parallel to the plane required to make the object to begin to move up the plane. So if we have a force in this direction parallel to the plane, now we're looking for the force, the least force that is required to move this object up the plane. If for example we have someone here dragging this object up the plane, we're looking for the least force that this person is going to apply to drag the object, to move the object, to make the object to begin to move up the plane. So let's name the force P. Now as this person is dragging this object up the plane, there's going to be an opposition. There's going to be a limitation to the movement of the object, and this is where our frictional force comes in. This is where our frictional force comes in to oppose and limit the movement of this object up the plane. And let's represent our frictional force with F. Alright, so the movement of this object, the force required to move this object up the plane must be equal and opposite to the summation of the forces in this direction. Alright, so what we're simply going to say is that P is equal to W sine 36 plus F, and that is how we can calculate the force parallel to the plane. So let me clear this out so we have more space to work. In the previous video we talked about coefficient of friction, in the introductory video rather, and we said that coefficient of friction is represented with mu, and mu is equal to the frictional force over the normal force. So we're representing our frictional force with F, we're representing our normal force with R. And so when we cross multiply, our frictional force is equal to coefficient of friction multiplied by normal force, which is mu R. Alright, so we can come back here and say that P is equal to that P is equal to W sine 36 plus mu R. Alright, so we have P to be equal to W sine 36 plus mu. Now your R, your normal reaction, is equal and opposite to W cos theta. So we can conclude that R is equal to W cos theta. So we're going to have it as W cos theta. So our theta is 36, so we have W cos 36. W cos 36. In the introductory video, we also said that coefficient of friction is the same as tan of theta, and we actually proved this formula, so you can also check that out. And so we can say that our coefficient of friction is equal to tan 36. So coming back here, we can conclude that P is equal to W, which is 150 Newton, multiplied by sine 36 plus mu, which is tan 36, multiplied by 150 cos 36. So we can impute this directly into our calculator, and finally we get our answer, our final answer, as 176.335 Newton, and this is the least force that is required to make the plane to begin, to make the object to begin to move up the plane. Thank you very much for watching. Don't forget to leave a comment, like, share, subscribe, and click on the video you are seeing on the screen, on your screen right now. Bye.